Hi guys, today I will show you how to identify any extrema of two or more variables functions. We have z is equal to x squared plus xy minus 0.5 y squared minus 2x plus y. First of all, we need to find critical points and we need to use partial derivatives for it. We will use first of all delta z over delta x. As you know, we will consider all x's as variables and all other variables like constant numbers. And for example, x squared's derivative will be 2x plus, we will use y as constant and it will give us y, and minus, it will be 0, minus 2 plus 0. And we can consider it like 2x plus y minus 2. And secondly, we will find delta z over delta y. It will be 0 plus x, 0 y, 0 minus 0 plus 1. And also it will be x minus y plus 1. And we will equal them 0 to find our critical point and find the common points. We will 2x plus y minus 2 equals to 0. And let's find y from here. Y will be 2 minus 2x. And let's choose for second condition. We will have x minus y plus 1 equals 0. X is equal to y minus 1. If we will change the y with here, we will get x is equal to 2 minus 2x minus 1. And it will give us x plus 2x equals to 1. 3x will be 1 and x will be 1 over 3. And from here we can find y also. Y will be 2 minus 2 multiply y 1 over 3, and it will give us 4 over 3. So guys, we found our points, and so guys, now we will find the second derivative of x and y. We can write it here like an arrow. It will be delta square z over delta x squared equals to 2 and plus 0 minus 0. That's it will be 2. And it will delta square z over delta y squared equals to minus 1. And we should also find the delta z, delta square z over delta x, delta y. It will be the derivative related to y from this, and it will equal to 1. You can find also delta square z over delta y, delta x. It will be the same answer like this. You can find x derivative is 1, again 1, it will be same. Next step, I wrote here for not forgetting them. I will write all conditions and we will check all of them for finding all extremas, which is, for example, is it local maximum or minimum or saddle point. I'll write all conditions here. First one is if delta square z over delta x squared is greater than 0 and delta square z over delta x squared multiplied by delta square z over delta y squared minus delta square z over delta x delta y square less greater than 0, it will give us local minimum. And for the second step, it will be the same. I will write quickly. But we will use less than 0 here. And delta square z over delta greater than 0, it will give us local maximum. And for the last step, we will find if delta square z delta x square multiplied by delta square z delta y square minus delta square z delta x delta y square less than 0, it will give us a function has a saddle point at AB. We found the AB because our x is 1 over 3, y is 4 over 3. It means our point is 3, 1, and 4 over 3 is our point. Now we will check all of them. Let's check first one here. Let's check all of them here. You can see that it's greater than 0. Yes, 2, it's greater than 0, but here it's less than 0. We can say that it's not true from the beginning. Now let's check this AND condition. 2 multiplied by minus 1 less minus, it's 1 square greater than 0 will give us minus 3 less than 0, not correct, and it's also not right. Let's check third one. As you see, our result is same, minus 3 less than 0. It means our function has saddle point at 1 over 3 and 4 over 3. That's all, guys. I think I explained it clearly and you understood everything, and you can apply these rules for your multiple variables functions and it will be the same answer. Also, you can have some two powered functions, which is you can find more points. You will just check them, you will find all answers clearly. Thanks for watching. See you next time.